Hey guys, today we are finding the x and the y intercepts. The x-intercept of a function is where the graph crosses the x-axis. To find the x-intercept of a function, we want to find the value of x when y is equal to 0. So what I mean by that, if you look down here at my little graph, if you notice we have a line, and the line is going through the x-axis. Here's my x-axis, and the point where it intersects, in this case, 1, 2, 3, we're at 3, 0. That would be the x-intercept. So you notice it crossed right there at the x-axis. Okay, and here is my y-axis. So the point where it crosses the y-axis is right here, which would actually be at 0 and 3 in this case. Okay, so for the x-intercept, notice because it's crossing the x-axis, is actually the same as finding the 0 of a function. So the same as finding the 0. Okay, the y-intercept of the function is where the graph crosses the y-axis. To find the y-intercept of a function, we want to find the value of y when x is equal to 0. All right, so if we have an example, 2x plus y is equal to 28. First, we're going to find the x-intercept. So if I find the x-intercept, I always like to let my y be 0. All right, and every place I see a y in that function, I'm just going to put in a 0. So I'm left with 2x plus 0 is equal to 28. 2x would be equal to 28, and then I would divide both sides by 2, and my x would be equal to 14. So my ordered pair, the x-intercept, would be 14, 0. Okay, if I'm finding the y-intercept, I want to let my x be 0. So I'm using the same function here, 2 times, in this case, my x would be 0, plus y is equal to 28. I'm left with 0 plus y is equal to 28, or my y is actually equal to 28. So the ordered pair would be 0, 28. All right, number 2, if I want to find the x-intercept, okay, I'm letting my y be 0. I'm going to plug in 3x plus 2 times my y is 0 is equal to 6. 3x plus 0 is equal to 6, or 3x is equal to 6. And I divide both sides by 3. My x is equal to 2. So my x-intercept is 2, 0. My y-intercept, I want to let the x be 0. All right, I'm using, again, the same function, only now my x is 0, so it's 3 times 0 plus 2y is equal to 6. Okay, 0 plus 2y is equal to 6, or 2y is equal to 6, and then when I divide by 2, both sides, I get y is equal to 3. So my y-intercept is going to be at 0, positive 3. All right, I want you guys to pause the video right now, and I want you to try the next two, number 3 and 4. Okay, as soon as you're finished trying them, I want you to come back and let's see if you got the answers right. Okay, well, welcome back. Number 3, let's find the x and the y-intercept for the function. So I'm going to clear out this here. Okay, my x-intercept, again, I'm going to let my y be 0. And when I do that, I've got 5x minus 0 is equal to 35. Or 5x is equal to 35. Divide both sides by 5. And my x is equal to 7. So my ordered pair is 7, 0 for my x-intercept. My y-intercept, I want to let my x be 0. And when I do that, I've got 0 minus, 5 times 0 minus y is equal to 35. Or 0 minus y is equal to 35. I'm left with negative y equals 35. So when I divide both sides by negative 1, my y is negative 35. So my ordered pair would be 0, negative 35. All right, looking at number 4. My x-intercept, again, let my y be 0. All right, so I've got 3x minus 3 times 0 equals 9. 3x minus 0 equals 9. 3x is going to be equal to 9. I divide both sides by 3, and my x is equal to 3. So my ordered pair is 3, 0. Now for my y-intercept, I'm going to let x be 0. When I do that, I've got 3 times 0 minus 3y is equal to 9. 0 minus 3y equals 9. Or negative 3y is equal to 9. So when I divide both sides by the negative 3, I get y is equal to negative 3. My ordered pair is 0, negative 3. Okay, moving on, we want to use the intercepts to graph an equation. So we're going to find the x and y intercepts of the function and then graph it. So going back to what we just did, we're going to find the x-intercept, and to do that, we're going to find the x and the y, but we'll start with the x. We'll let our y be 0. All right, so we've got negative 3x plus 9 times 0 is equal to negative 18. So I've got negative 3x is actually going to be equal to negative 18. And I'll divide both sides by negative 3. So x is going to be equal to 6. So when I have the graph, I've got the ordered pair is going to be 6, 0. So if I graph it, I'm going to go, my x is 6, so I'm going to go to the right 6. And right there on the x-axis, there's my x-intercept. All right, now my y-intercept, I'm going to let my x be 0. And when I do that, again, I'm using the same function. I've got negative 3 times 0 plus 9y is equal to negative 18. I'm left with 0 plus 9y is equal to negative 18. Let's just write it as 9y equals negative 18, so that when I divide both sides by 9, my y is actually equal to negative 2. So my ordered pair is 0 and negative 2. So my y is going to be right here. Okay, so with those 2 points, I can now connect them and draw a line. And there we go, we graphed our first line. Okay, and we did that with intercepts. Now I want you guys to try the next one. So pause the video and see how you do. Okay, now you should be coming back and let's check it. Finding the x and y intercepts. So for our x-intercept, let's let y be 0. So every place I see a y in this function, I'm going to put a 0 is equal to 1/2 x minus 3. And I'm going to solve for x. So I'm going to add 3 to both sides. 3 is equal to 1/2 x. All right, now I'm going to divide both sides by 1/2 or multiply both sides by 2. So when I do that, I've got 2 times 3 is equal to 1/2 x times 2. Multiply both sides by 2. 6 is going to be equal to x. So my x is 6 and my y is 0. And then for my y-intercept, I'm going to let x be 0. All right, when I do that, y is going to be equal to 1/2 times 0 minus 3. Y is equal to 0 minus 3. So my y is actually negative 3. So I've got a 0 for my x and a negative 3 for my y. So when I graph that, I've got my x-intercept is at 6, 0, so it's going to be right here. And my y is going to be at 0, negative 3. Okay, again, I connect the 2 points like that, and there we go. Okay, all right, moving on. Okay, so now in the next example, we have the function negative 4y is equal to 12. So if we want to set our x-intercept, okay, we want to let the y be equal to 0. Okay, when we do that, we're left with, well, look at that. Actually, we're going to set our y, so it's going to be negative 4 times 0 is equal to 12. Well, that gives us something kind of funky. So that means there's actually not going to be an x-intercept, so no x-intercept. All right, but now for our y-intercept, okay, for our y-intercept, let x be equal to 0. In this case, there is no x, so we're just going to solve for y. Negative 4y is equal to 12. We divide by negative 4, and we get y is equal to negative 3. So our y-intercept is at 0 for our x and then negative 3. So it's going to go right here. So we're only going to have the y-intercept. Well, actually, what happens in this case, this is an example of a horizontal line. And if you notice, it never ever will cross the y-axis. Okay? I mean the x-axis, sorry. It never crosses the x-axis. So it's only going to cross the y-axis here, right here at 0, -3, but it will never cross the x-axis. So looking at another similar example, only in this case we've got 2x is equal to 8. So our x-intercept, okay, we want to let the y, let's set this out here, whoops. Okay, so the x-intercept, let's let y be equal to 0. In this case, there is no y, so there is no y-intercept, but with our y-intercept, let's let, actually, let's stop here for a second.